Good morning, you guys. All right, Unit 6, Chapter 12, Air. What kind of pollutants are found in air and what can be done about them? There's supposed to be a little C right there. So what causes air pollution? Air pollution, we're going to zoom in a little bit better. Air pollution. Ooh, let's change our colors. Purple. Air pollution. Harmful substances in the air, so it can be a solid, a liquid, or a gas. Most of it is the result of human activities, unfortunately. But there are some natural sources too, such as volcano, dust, pollen, spores. The primary pollutants, those are put directly into the air by human activities. Those include soot from a smoker, carbon monoxide. We all know about carbon dioxide, right? Carbon dioxide, CO2. Carbon mono 1, CO. That's produced by cars, trucks, buses, industrial processes. Those are going to interfere with the blood that carries oxygen. It can make you sleepy and eventually cause death. If you've ever heard of carbon monoxide poisoning, that's why the carbon monoxide is going to prevent the oxygen from being carried to your brain. That's why it makes you sleepy at first and lead to death. Nitrogen oxide. Those are burning fuels in vehicles, power plants, boilers. Okay, these lead to lung infections, haze, acid rain. Sulfur dioxide, CO2. This is caused from the burning of fossil fuels. I'm changing my color. And you guys have been really good. I just want to gently remind you again, don't forget your 3 colors, your 3 questions per page, and your summaries, okay? Volatile organic compounds, VOCs, those are burning fossil fuels, vehicles. This leads to smog and cancer. There's really been a lot of change in the atmosphere ever since a lot of the countries have shut down their industrial plants. Since the coronavirus has come into play, and you can actually see a lot of smog has really decreased. Particulate matter, PM, construction, agriculture, fires, industrial root processes, clouds, respiratory problems, corrosion, erosion. These are all problems that occur from particulate matter. So right here you've got a picture that shows and explains. So you've got the car right here. The car's exhaust reacts with the air and the sunlight. It's going to form the ozone. Eventually the ozone reacts with the automobile exhaust to form the smog. Okay? For a while, good Lord, when you would fly into a city, like we're talking LA, Houston, Miami, Paris, Hong Kong, oh Lord, the smog was so bad you could actually see it. If you were driving into town or flying in, you could actually see the layer of smog. And the reason you knew it was smog was because on the weekends, when there was less people driving into the city, there was less of it. So it's kind of crazy. Secondary pollutants forms when a primary pollutant mixes with another one or with natural substances and a chemical reaction takes place. This is what we call ground level ozone. 2 major sources of air pollution in urban areas are motor vehicle emissions and industry. How vehicle emissions are controlled. You've got the elimination of lead in gasoline. So when you go to get gas in your car and it says lead free, that's why, right there. That's the number 1 reason. I'm gonna change my colors again. Let's do orange. Catalytic converters. Ooh, I like that orange. All right, they're actually going to clean a lot of pollutants from your car exhaust. That's your tailpipe emissions. We're going to slide 1 real quick. Okay. So, right here you've got your engine. Okay, the exhaust leaves the engine. It's going to go through this particulate matter that it's going to trap it in the diesel particulates filter. Yeah, no way am I going to make it fit in there. And I didn't even tell me, well then, Miss Ogden, why should we? You know what? You're not writing with a computer pen, so don't even try me, okay? It's easier. You can also do the same thing I just did, because you know what? Yeah, it's a really small box. Sorry, that was my bad. All right. The DEF is injected into the exhaust, and then from there you've got the nitrox, which is reduced in the SCR catalyst, and reduced volume of emissions. Do I know what all these initials stand for? No. Should I? Yes, and shame on me. I meant to look it up beforehand, and I didn't, so apologies. I'm going to do it really quickly. Leaves the tailpipe, particle matter, and nitrox near zero levels. So thanks to catalytic converters, car industries, automobile industry, has really been able to minimize a lot of the pollution that's coming out of cars. Not completely zero, but when it comes to particulate matter, the filters really have done a good job. However, if we don't keep our cars properly tuned, properly cleaned, our filters cleaned up, not good for the car, not good for the environment, not good for anybody, right? Okay, so DF, let's look that one up. DF and SCR. DF, catalytic converter. Oh, DF for defined catalytic converter. Oh, no. DF, catalytic converter. Let me look at this up. In regards to catalytic converter, diesel exhaust fluid, diesel exhaust fluid. So the diesel exhaust fluid is injected into the exhaust right here. Boom. So it's kind of sprayer mister to kind of catch the particulates and weigh them down. Makes sense. And then the SCR catalyst. That's selective catalytic reduction. It's an advanced active emissions control technology system, and it injects a liquid reductant agent through the special catalyst. So it's again to heavy down. It's all about getting those particulates weighed down so that they'll stay stuck to the filter and not be released in the emissions. Okay? See, and y'all thought you were only going to learn about the environment. Look at that, we're looking about cars. Okay. Seriously, this is cool stuff. Electric cars have zero emission vehicles, but it has to be said that the batteries, in order to have the proper metals we need for the batteries for electric cars, we're having to mine things in the earth in order to have the batteries last. That is causing problems in that end. So yes, electric cars are great for the environment. However, there's a disadvantage by having to find the minerals we need for the batteries for those cars. And then we don't know how long those batteries are going to last. And then what do we do with those batteries when they are bad? Like we said before, right? AA batteries that you use. Once they're done, you're not supposed to dispose of them in the trash. At the same time, there's no good way to dispose of them properly, recycling-wise. So what do you do with them? So never mind a big old car battery. So there's no easy answer. So what do we do? Does that mean we give up? No, it just means we keep trying to do our very best. That's all we can ever do. Okay? How pollution from industry is controlled. All right, well, you use scrubbers to remove the pollutants. This is what's found in industries. Okay, these are gases moved through a spray of water. Whoa. Should have done that one. Apologies. Electrostatic precipitators remove dust particles. Smog, that is when air pollution hangs over a city and decreases visibility. And that forms when car exhaust reacts with the air and the sunlight to form the ozone. The ozone reacts with the exhaust to form the smog. It's kind of a whole setup. I'm going to change my color again. I really like this color thing. Pink. All right, air circulation. It keeps pollution levels in check so they don't get dangerously high in one area. Warm air, right? Warm air rises. That's why you're not going to have a lot of two-story homes in Florida. Warm air moves up and carries pollutants away from the Earth's surface, but it can be trapped by a temperature inversion. Okay, temperature inversion. So let me do this. So you've got solar radiation, right? And you've got these escaping pollutants. So the pollutants are going out. They're going like cool air, and warm air. So warm air, right? It goes up, warm air rises. There's cool air, we're fine. Now, we've got these right here. You can see that the pollutants are trapped. What's different? You got cool air, but then for some reason, you have this warm layer right here. Okay, and because of this warm layer right above that cool air, it traps all those pollutants. This is very common. Notice in the background you've got these mountains right here. This can happen a lot in land that's in the middle of your actual land that's in the middle of mountains. So if it's a valley surrounded by mountains, they tend to be really prone to this kind of situation. So if they've got a warm air that's coming right above it, then it's going to be a problem for them because they're going to get everything trapped. Discard. Thomas? Flash. Sorry, kiddos. All right, so temperature inversion, atmospheric situation where cool air is trapped, where cool air is trapped close to the Earth's surface by a layer of warmer air above. Okay, the pollutants can't rise away. This could happen if a city is located in a valley surrounded by mountains. All right, I'm switching colors again. Let's go to green. Ooh. Air pollutants can cause a lot of health problems, especially dangerous for people that are young, very old, people with heart or lung problems. Short-term health effects can include nausea, irritation of mucous membranes, respiratory trouble. Long-term health effects, thank you, emphysema. Emphysema is an illness related to the lungs, okay? Lung cancer, heart disease. Air pollution can happen indoors. You wouldn't think it, but it really can. Poor air quality inside would be a situation that would lead us to having poor health quality. Oh no, if I can make it one, let's do liquid. It can be caused by plastics, believe it or not, and chemicals, carpets, building material, paints. And there's something called the sick building syndrome. If you start noticing, say you're older and you've got this job and you start noticing everybody around you is getting sick all the time and having issues with bronchitis, pneumonia, asthma all of a sudden, right? You start noticing people getting problems. Well, you might want to start looking at the quality of the building you're in. Now, you'd be surprised. So this is a home. This is not even a building. This can be a home, right? Because it could be you have in your home, in your apartment, and where you work. It can happen anywhere. So you have to be aware of the possible dangers around your home, around wherever you are. Because again, environmental science, it's not just about the planet or saving the environment. It's about where you are, what's around you. So keep that in mind. All right, bleach, sodium hydroxide, hydrochloric acid. These are all things that you might use in your bathroom. If you mix these, it can cause it to be very, very, very toxic. Okay, nitrogen oxides. If you have a gas stove or a wood stove or even kerosene heater, right? A lot of times when it gets cold outside, if you bring in a kerosene heater inside your house, it's going to release toxic fumes and it can be deadly. You have to watch out. You can have fungi, bacteria from dirty heating and air conditioning ducts in your home. All right. You can have carbon monoxide. Remember CO. Carbon monoxide can start be releasing from your faulty furnace or your car if it's left running inside a garage. Methylene chloride from paint strippers and thinners. You might have old paint in your house, in your garage, or paint thinner. Okay, Radon, 222. From uranium-containing rocks under the house, okay? Not common, but it can happen, okay? Gasoline. If you store gasoline, right? You might store it over the winter. Be careful with that. Okay, formaldehyde. You can have formaldehyde in your furniture, your carpeting, your particle board, your foam insulation, your clothes, right? That's why they're telling us nowadays to make sure we wash our clothes, okay? Because there's formaldehyde in our clothes. It's used as a pesticide repellent. So in order for the clothes not to get eaten by bugs during transport, during storage in stores, they have formaldehyde in them. Well, that's kind of, that's the same stuff that we used to put animals in, preservative in. We're no longer allowed to use anymore because it's carcinogenic. It's cancer causing. Well, some of our stuff has it, so be careful. Tobacco smoke, okay, from cigarettes and pipes. Pentachlorobenzene from mothballs, crystals, and air fresheners. Be careful. Tetrachloroethylene from dry cleaning fluid. Okay, am I telling you to freak out and nothing is safe in your home anymore? No. I'm just saying be aware. If you start noticing a lot of people in your family being sick, or a lot of people at work being sick, you might be wondering if maybe that's what's going on. Sick building syndrome. Okay. Okay, so how can you prevent air pollution? Indoor air pollution. All right. Remove sources of air pollution. Improve ventilation. Because if you're going to mix indoor with outdoor air, if there's something inside your house, the outdoor air is going to mix in. It's going to make it a lot better. All right. Radon gas. Colorless, odorless, tasteless, radioactive. From the decay of uranium, this can cause lung cancer. I'm changing color. Ooh, galaxy. We're gonna go with gold. Some gold. Okay, asbestos. You've probably heard of asbestos. Long, thin fibers, resistant to heat, very strong. Uses insulation and fire retardants. If you have a home that was built in the 50s, chances are there's asbestos in the insulation. Okay, when inhaled, it will cut and scar the lungs. Noise pollution. Wait a second, Miss Falk. Noise can be pollution? Oh, yes, ma'am. Yes, sir. You better believe it. Faintest sound heard by the human heart, that's 0 decibels. dB stands for decibels. A whisper is 30, conversation 60, lawnmower is 90. Portable CD player, okay, think of your headphones now. 90 to 120. Chainsaw is 100. So some of you guys are listening to music above the level of a chainsaw. That tells you how much damage you're doing to your hearing. Car horns 110, a rock concert is 120, a jet engine is 140. So y'all are listening to music only 20 decibels below a jet engine. And then a rocket that goes into space is 180. So 120 is the threshold of pain. Exposure to sound over 120 can result in permanent deafness. Airplanes, traffic, factories, mowers can cause hearing loss. High blood pressure, y'all know how I get with the tapping, right? Stress, and loss of sleep. Another type of pollution you may not think of is actually called a light pollution. It's not directly bad for people, but it can hurt the environment. All right, energy waste. Incredibly wasteful because you can't see the night sky. Solutions: have direct light shining downward. Use time control to use a light only when needed. Have low pressure sodium source of light. We know about night light because of the sea turtles, right? Right now it's nesting season. One of the best nesting seasons we've ever had. So we don't want any lights on because we want the turtles to go back out to the ocean. And during hatching season, we definitely don't want any kind of street lights on, any white lights, because the hatchlings will go towards the white light thinking it's the moon. So if you have special lights on, then it's okay, because it's not going to attract the hatchlings. The hatchlings are going to go towards the moon, out to the water, off they go. Acid precipitation, that is rain, sleet, or snow that contains a high concentration of acids when fossil fuels are burned. So fossil fuels, you notice that's a common denominator in a lot of our pollution, okay? When fossil fuels are burned, They release sulfur oxides and nitrogen oxides. These oxides are going to combine with water in the atmosphere. They form sulfuric and nitric acid. It falls as an acid precipitation. The pH is going to measure how acid or basic something is. 7 is going to be neutral. Lower acids, higher pH, or is it going to be a base? And natural precipitation is a little acidic, but acid precipitation is even less than a pH of 5. Okay, and kind of give you an example, a reference point. I'm going to show you. All right. Actually, we're almost done, so let me go ahead and finish. Problem: pollutants can be released in one area and fall to the ground far away. So it is a global concern and needs cooperation. Countries are enacting international agreements to control precipitation. So areas, green are areas that produce the pollutants that lead to acid precipitation. So the green, right, there's a lot of it. Areas suffering from acid precipitation. Well, wait a second. Parts of Canada are dealing with acid precipitation when they're not even releasing the pollutants for it because the wind is carrying it. The air currents of the planet are carrying it further than when they're getting released. Okay? A lot is getting released in Russia. It's carrying over into Western Europe. Okay? Or Southern Europe's getting carried north into Western Europe again. Okay, areas that are at high risk for acid precipitation problems. Look at that. You got parts of Africa that are high risk, parts of South America. When they're not even producing anywhere near the high amounts of pollutants that are causing the acid precipitation. Does that make sense, you guys? All right, look at that. We're dealing, believe it or not, we have acid precipitation issues when we're not even releasing pollutants. So it is a global issue. All right, 2 more slides and we're done. pH scale. All right. So what comes first in the number line? 0 or 14? 0, right? What comes first in the alphabet? A or B? A. So less than 7, you're an acid. Greater than 7, you're a base. Smack dab in the middle, you are neutral. Okay? You got Here we got lemon juice. This is vinegar. So 5 tomato juice. Have you ever had tomato juice? That's about a 4.5. So any acid precipitation is anything below here. So tomato juice, soft drink, so Coca-Cola. So imagine us pouring Coca-Cola all over the planet. That's essentially what we're doing, guys. We got to stop. Milk is right here. We tend to think of if we eat something spicy, we should drink milk. Makes us feel better, but it's actually not. Or if you have, it's not for spicy. It is true for spicy. I meant for if you have heartburn. Problem is heartburn is stomach acids that are coming up, and your stomach acids are right about here, about a pH of 1. Milk is not going to help because it's still an acid. You need to go all the way over here. I am not saying drink bleach if you have, acid stomach. I can't talk. Stomach reflex. Don't do that, okay? But you want to take antacids, which are right about here. Here are your detergents. Any kind of cleaning product, except for vinegar, is going to be over here on your basic scale. Okay? Impacts of acid precipitation. How does it impact soil and plants? Plants are adapted to specific water and soil pH range. So you start messing with that, it's going to cause them to have big issues. The nutrients are going to be leached away, and that means they're going to be sucked out of them. Okay? Toxins are going to be released. Big problems. So how does it affect aquatic systems? Acids can actually kill the fish because, again, these guys are only used to that certain range, that homeostasis, that certain range. Acid shock. If all of a sudden a bunch of snow melts and brings down all this water that's got a very, very, very low pH, so an acid pH, all at once, it's an acid shock, and it can kill a lot of organisms. How does it affect humans? It can release toxic metals into the environment. It can get into our crops, so the food that we eat. Health, respiratory problems, decrease the standard of living. By affecting fishing and forestry, it can corrode or erode away buildings, sculptures, and monuments. Okay, good news is we can do something about it. All right, coming together as a world, we can do something about it. All right, guys, and that's it for chapter 12.